Armalite AR-15, prototype between 1957 to 1959. Eugene Stoner shrank the AR-10 and made something light and clever. Wright sold to Colt in 1959 and mass production followed. Colt M16, adopted in 1964. Colt turned the Armalite prototype into the M16, still a 20-inch barrel and direct impingement. Early twist rates were for 55 grain M193, 1 to 12 twist rate. The service guns were select fire, full and semi. Early U.S. adoption pushed the rifle into combat in Vietnam, but these first M16 rifles lacked chrome-lined chambers and forward assists, combined with corrosive powders and inadequate cleaning that led to severe reliability problems in the field. M16A1, standardized around 1967. The M16A1 fixed the worst flaws. Chrome-plated chamber and bore to fight corrosion and stuck cases. A forward assist plunger gave soldiers a manual way to close the bolt. The three-prong flash hider gave way to the birdcage style to reduce snagging and dust signature. 30-round magazines replaced the 20-rounders. Improved buffer and bolt design cut cyclic rate and reduced felt recoil. Issuing cleaning kits and changing powders made the rifle reliably serviceable in Vietnam. The A1 marked the transition from problematic prototype to dependable service rifle. Car-16 in the late 1960s. Compact takes on the AR idea surfaced quickly. The Colt Commando, aka the XM177 family, shrank barrels to approximately 10 to 11.5 inches barrel. Collapsing stocks and short overall lengths made these ideal for jungle and vehicle use. Downsides showed up fast. Reduced range, louder muzzle blast, and gas ballistic problems from short dwell times. Engineers experimented with moderators and muzzle devices to calm the flash and pressure. These short-barreled experiments foreshadowed later carbine engineering challenges. M16A2, the early 1980s. 2 decades of combat feedback shaped the next major revision. The M16A2 arrived with a heavier forward barrel profile to resist heat and bending. Rifling shifted to 1 to 7 twist rate to stabilize the 62-grain M855 SS109 NATO round. Full auto was replaced by a 3-round burst to control ammunition expenditure and improve controllability, though the burst cam made trigger pull inconsistent. The rear sight went fully adjustable for windage and elevation. Furniture improved, round 2-piece handguards, stronger stock, and a more ergonomic pistol grip. The A2 traded some weight for durability, long-range capability, and soldier-friendly ergonomics. Colt Canada, C7-C8, the mid-1980s. Canada took a different path. The C7 blended A1/A2 features but kept full auto instead of burst, avoiding the A2's controversial burst cam. Cold hammer-forged chrome-lined barrels improved life and durability. Canada preferred a simpler rear sight and a slightly shorter stock for ergonomics. The C7 later added a flat-top upper, C7A1, to accept optics early on. The C8 carbine paralleled the emerging M4, but with Canadian design choices that emphasized reliability and service life. The C7 and C8 family influenced many NATO procurements and demonstrated the AR platform's adaptability. Civilian market growth in the 1994, which was the assault weapon ban era. After Colt's patents expired, other manufacturers flooded the civilian market. The AR's modularity made it wildly popular among sport shooters, competitors, and hobbyists. The 1994 federal assault weapons ban, that was between 1994 and 2004, limited certain features for a decade, but innovation continued, often in post-ban compliant forms. By the ban's sunset in 2004, the platform had a massive aftermarket ecosystem: rails, optics, triggers, and caliber conversions. The AR had become both a military staple and America's rifle for civilians. Colt M4 Carbine, 1994 adoption. The M4 shortened the M16 to 14.5 inches barrel length with a carbine-length gas system. It added a 4-position telescoping stock and retained the A2 style burst at issue. Engineers tuned feed ramps and port sizes to maintain reliable feeding at shortened length. The M4 offered nearly rifle-like performance in a much more compact package, ideal for urban and mechanized operations. It quickly became the standard carbine choice for troops who needed maneuverability without sacrificing too much range. Flat-top uppers and the M16A4, late 1990s. The move to optics drove the flat-top revolution. The M16A4 replaced the fixed carry handle with a detachable one and a full-length Picatinny rail on the upper receiver. Optics like ACOGs and red dots became common. Rail systems like the Knights Armament M5 quad rail enabled mounting of lights, lasers, and grips, turning the AR into a modular platform. This was the moment the AR shed its strictly iron sight identity and embraced modern accessory ecosystems. The SOPMOD program in the late 1990s to 2000s. Special operations units led accessory integration. The SOPMOD program equipped M4s with optics, IR lasers, lights, suppressors, and quad rails. The Knights Armament M4 RAS and later Free Float Daniel Defense RIS-2 handguards freed the barrel from contact and improved accuracy and zero retention. The modular AR became a customizable system for mission roles. direct action, night ops, reconnaissance. Accessory integration became a major part of the AR's value proposition. M4A1 and the SOP Mod M4 Block 2 in the 2000s. SOCOM favored a full-auto M4A1 with a heavier SOCOM profile barrel for sustained fire. The M4A1 removed the burst cam and offered a true semi-full-auto trigger group. Heavier buffers, like H2 and H3, smoothed cycling and improved reliability on short barrels. The SOP Mod Block 2 moved toward free-float rails, improving accuracy under accessory loads. These changes hardened the carbine for high round count combat and accessory-heavy setups. Mark 18 CQBR, short upper, early 2000s. The Mark 18 CQBR brought a 10¼ inches upper to the M4A1 lower. Engineers enlarged the gas port and tuned extractors and gas rings to deal with the short dwell time. Heavy buffers and robust extractors became standard to prevent failures. Suppressor compatibility and QD muzzle devices were often part of the Mark 18 kit. Ballistically, it sacrifices velocity and range, but it gains exceptional handling in close quarters. The Mark 18 became a go-to CQB solution for Spec Ops operators and SWAT members. The Piston Revolution and HK416 in the mid-2000s. High round counts and harsh environments spotlighted direct impingements, fouling, and heat issues. Heckler & Koch's HK416 introduced a short-stroke gas piston into an AR pattern design. The piston moved the fouling out of the receiver, keeping the bolt carrier group cooler and cleaner. And Cold Hammer forged chrome-lined barrels and robust carriers increased service life. And HK416 rifles showed fewer stoppages under sustained fire and fouling. They cost more and weighed a bit more, but reliability in adverse conditions made them attractive to special units and several national forces. M27IAR, this is the HK416 derivative back in 2009, so U.S. Marines adopted a modified HK416, 16½ inches barrel, as the M27 infantry automatic rifle. It paired a heavy-profile Cold Hammer forged barrel with the fully automatic capable trigger group to deliver sustained, accurate fire at squad level. The M27 demonstrated that a piston-driven AR could perform in volume fire roles traditionally filled by belt-fed guns, and influenced force-level thinking about small arms roles. Mark 18 Mod 1 and free-float rails, mid-2000s. Mark 18. Mod 1 variants adopted free-float rails like the Daniel Defense RIS-2 to improve accuracy and keep accessories from touching the barrel. Free-floating reduced zero shift under accessory loads and was a major jump in usability for suppressed CQB uppers. These Mod 1 uppers emphasized reliability and accessory friendliness. Rise of advanced materials and coatings, 2010s. Manufacturers moved beyond basic finishes. Nitriding, melanite/Nicor, treated barrels for long life and corrosion resistance. Bolt carrier groups received something like the nickel boron, NP3, or DLC coatings to cut friction and ease cleaning. And Cold Hammer forged barrels became more common at higher price points for longevity and accuracy. Monolithic upper receivers, carbon fiber handguards, and lightweight fluted barrels started to appear in match and special purpose builds. These tech leaps improved durability and reduced maintenance without changing the AR's fundamental architecture. Ambidextrous controls, monolithic uppers, and quick change barrels. Designers focused on ergonomics and mission adaptability. Ambidextrous lowers, mag release, bolt catch, safety became common on modern military pattern rifles. Monolithic uppers that integrate receiver and rail increased rigidity and accuracy. Some systems added quick change barrel capability for rapid roll swaps. These features made the AR friendlier for varied statures, left-hand shooters, and multi-role units. Magazine and ammunition evolution. Magazines improved with better followers and polymer construction. Magpul P mags proved highly reliable and gained formal military acceptance. The M855A1 enhanced performance round entered service and offered better terminal effects. It also increased stress on bolts and barrels, prompting stronger parts and revised maintenance practices. Magazine reliability and ammunition advancements were as crucial to field performance as barrels and gas systems. Precision ARs, SPR, and DMR rifles. The AR proved adaptable to precision roles. Match barrels, free-float handguards, tuned triggers, and specialty chambers like the 223 Wild. It has turned ARs into 600-yard tools. The Mark 12 SPR showed the platform's potential. Low-power variable optics blurred the line between carbine and designated marksman rifle. The AR's modularity let units reconfigure a basic receiver into a CQB tool or a precision pick. The monolithic and ambidextrous evolution, 2010s. Companies like LWRC and LMT pushed military-grade innovation. That means self-regulating short-stroke piston systems, monoforge integrated uppers, Nicor-treated barrels, meaning a much harder, more wear-resistant, and corrosion-resistant surface without adding thickness or altering the barrel's dimensions, and fully ambidextrous lowers for both lefties and righties. LMT's enhanced bolt carrier groups and quick-change barrel systems demonstrated how lessons from decades of service could be engineered into more robust, service-ready packages. These vendors showed there was still room to refine the AR without breaking its core design. U.S. Army moves and M4A1 conversions. The Army gradually favored M4A1 style full auto trigger groups over burst mechanisms and began converting or issuing M4A1s across units. Heavier buffers, SOCOM profile barrels, and updated rails became widespread. The general lesson: units wanted simpler, more reliable fire control and barrels that handled higher round counts without losing accuracy. Suppression, adjustable gas blocks, and integrability, 2010s to 2020s. Suppressors became common in doctrine. Adjustable gas blocks and two-position regulators allowed rifles to be tuned for suppressed or unsuppressed firing. This reduced overgassing and wear and improved long-term reliability when suppressors were attached. It also highlighted the practical need for user-tunable gas systems across both DI and piston platforms. International adoptions and HK416 spread in the late 2000s to 2020. Countries began choosing piston-driven AR derivatives for their reliability benefits. Norway adopted the HK416 in 2008. France chose the HK416F in 2017 to replace FAMAS. Germany selected the 416 variants in the early 2000s. The HK416's battlefield pedigree, including high-profile use in operations like the 2011 Bin Laden raid, pushed many militaries to rethink DI-only solutions. Still, DI rifles remained dominant due to weight, cost, and logistics. The modular mounting era. M-LOK replaces quad rails in many places. After the quad rail era, light, modular attachment systems like KeyMod and especially M-LOK became popular. M-LOK reduced weight and bulk while letting users place accessories only where needed. It matured into a near standard on barrels and handguards across military and civilian markets. The next generation squad weapon and the XM7, 2022. The U.S. Army's NGSW selected a SIG MCX Spear variant designated XM7, firing a 6.8 by 51mm cartridge. This marks a doctrinal shift away from 5.56 NATO for some frontline roles. The new weapon isn't an AR-15, but it owes much to AR ergonomics and modularity. Adoption of XM7 signals that while the AR-15's era of dominance may wane for frontline infantry over decades, its design principles persist in next-gen rifles. Civilian market and caliber diversification. Civilian builders embraced caliber swaps. 300 Blackout for suppressed subsonic work, 6.5 Grendel and 6.8 SPC for longer reach or better terminal performance. Match ARs, lightweight carbon fiber parts, and precision uppers created a diverse civilian ecosystem. The platform's modularity made caliber change, roll swap, and customization straightforward, and that fueled a constantly renewing market of parts and ideas. Material science and lifespan improvements. Nitrided barrels, CHF barrels, nickel boron and DLC coatings, and stronger steels extended service life and lowered maintenance. Many manufacturers advertise barrel or part life far beyond earlier norms. These changes reduced the maintenance burden once associated with direct impingement designs. They didn't erase maintenance needs, but they widened acceptable cleaning intervals for high round count use. Ergonomics, charging handles, and modern controls. Charging handles grew larger and often ambidextrous. Stocks added QD sling points and adjustable cheek risers. Lower receivers incorporated ambi safeties and mag releases. Controls evolved to support left-handed shooters and tactical reload ergonomics. Small human factor changes added up to large improvements in real-world handling and malfunction clearance. The AR family proved itself as a kit platform. Ultra-short Mark 18 CQBRs for CQB, SPRs for designated marksmen, M27s as light automatic rifles. The same lower and fire control family could host different uppers to meet a unit's mission. That interchangeability became a logistical and tactical advantage. Fewer unique tools to maintain, faster roll swaps, and common training. So what have changed and what stayed the same? Gas systems is the first major change. It's DI versus piston, then it was barrels, profiles, and treatments. Later it was handguard rails, like quad to M-LOK for mount rigidity. Then it was about ambidexterity, coatings, adjustable gas blocks, and caliber options. So what stayed the same? The upper-lower modular split, the basic ergonomics, the inline recoil philosophy, and the detachable magazine box. The AR's DNA, modularity, adaptability, and user-driven customization remained intact even as parts evolved. As of the mid-2020s, the AR platform is everywhere. Military, law enforcement, and civilian. Some frontline military programs start replacing 5.56 ARs with 6.8mm systems for increased reach and penetration. Still, millions of AR pattern rifles will serve for decades given existing logistics, training, and platform familiarity. Expect continued hybridization, piston uppers where needed, DI where weight and simplicity matter, more ambi controls, suppressor-led designs, and adjustable gas as standard. If you like this type of content, be sure to drop a like and leave your comment on what you would like to see next.